Hey guys, I'm back. Thank you for joining me. If you are here, you're amazing. Actually, before we get anything started, for I guess just for history's sake, today is 8/18/2022. What is that? August 18th, and for Sting Brother Studios, for me and my brother, Arcane has been a huge inspiration to us. We absolutely loved it. It's been a huge motivation, and they were releasing behind the scenes. And I just hadn't seen it because I was like, it's behind the scenes. How, like, it's cool, but like I don't need to see it. But I did. I just watched the second episode, and man, the motivation of that show, of that process, is incredible. It's contagious. And for the record, I do consider me motivated. Probably won't be this motivated all the time, but for right now, I have this like feeling like we have to do this. We have to. People are gonna love it. It's like, this is what I want to do. I want to create the world, of harm. Something that people can enjoy and be a part of and like fall in love with, kind of deal, and continue the storytelling of games, of experiences, like motifs, I think the word is, just teaching people, feeling like drive. I need to be better even while watching / playing a game. I'm so motivated. I wasn't even gonna stream today's work, but I was like, this right here is an opportunity far beyond. This right here is an opportunity. A priceless opportunity. And I will make it happen. One way or another, I will make it happen. I don't care how long it takes. Well, I do, actually. I do care how long it takes. But it doesn't matter how long it takes, because it will get done. And our team is phenomenal. We have amazing people. Very, very talented. And we have what it takes. We have what it requires to put together an IP. Not just the game. I'm making the game, but the team is making the IP of Haurmon. Awesome. It's so cool. It's amazing. I'm so excited. I'm trying to get you guys hyped about it too, because it's gonna be incredible. It's gonna be incredible. So, thank you for coming along. And in the future, if I remember to come back and look at this, well done. Well done. So for today, let's turn that music back on. Write something down real quick. Gonna be in the ether. 05. Is it 18? 22. We have to. We will. We have to. gonna be freaking sick. Today, I forget what I put in the title, even though I just made it like 7 minutes ago. But we will be working on wall running. To be honest, we don't have the animations for it, but we do have an idea of how to do it because of a video. And that's exactly what I plan on doing. So regardless of if it looks perfectly seamless or not, this is gonna happen. This is going to happen, and I'm gonna get started on it. And thank you, me, last night. I put in a couple of animations for myself, and so now all I need to do is stitch it all together. Oh. Thank you, Arcane. I wouldn't say I want to be your rival, but if I am one day, I still love you. Also, holy shoot, we freaking made it. if we rival Riot's Arcane, best TV show, best animated TV show ever made. I mean, dang. Alright. Let's go back to that video that we were looking at yesterday. So this one is for first person template setup, but we're just gonna kind of like adapt it. We're gonna follow along, we're gonna adapt it. So let's do just that. Can I want to see the chat over here. Oh well. Okay. So, by the way, this video is by Davey, D-A-V-I-E, called Titanfall 2 Wall Running 30 Minutes, Unreal 4 Blueprint Tutorial Parkour Series number 1. So, if you like what you see and what I'm doing, take a look, support him, it's very cool. Or if you don't, then sorry, Davey. Okay.
So now that we have a fresh project, go ahead and open up your first person character. Now we're not actually going to do any code in here, just a setup for our component. So we're actually going to do all of our code in a component class.
Do we want to do that? Do we want to do all of our code in a component class? I'm gonna be on this player character. Benefit? because I think that when we run it to multiplayer, might cause some issues. Because like in a component, can you test it? Blueprints. Components. What? Component. Thank you. Component. Blueprint. Oh. Actor component. C underscore wall running. Player wall running. Put this now. Transfer over. Okay, in this. So we have like custom blah blah blah. We can we can do a component. Activate it or deactivate it. Get owner. Cast to player character base. Variable. Boom. That's what we need. And then player character base, so we can access it here. Maybe we don't need to.
So create a new folder. Components. Now in here, create a new blueprint. It's gonna be an actor component, and we'll call it parkour movement. Now we can go back to our first person character. We can add this. And now any code we do on here will actually work on the player character without us having to actually do code in there. Do on this. And now any code we do on here will actually work on the player character.
Okay, let's add it. Component. Awesome.
Without us having to actually do code in there. So now that we have the parkour movement component set up, we'll need a reference to our character. To do that,
Already
create a custom
done,
event.
my
From here, we can
friend.
pass in a reference to our character. To do that, the parkour movement. Now from here, we can pass
Goodness
in a reference
gracious, you're
to our
loud.
character. This will be of type character object. We can right click, promote this to a variable, call it character as well. We'll also need a reference to the character movement component. We can get that from the character. We can do the same.
So the way he's doing it, he's gonna call it from the character to initialize it. Might not be a bad idea. I'm just gonna call it from the component, so no need to write down anything. It's just gonna know. Character movement. We're gonna promote that to a variable.
Same thing here. Promote this to a variable. Call it character movement. Now, since we're going to be messing with the gravity, we're going to want a way to set it back to default so we can get a reference to the gravity scale here from within the character movement component, and then we can promote this to a variable and save it as default gravity. Next, we're going to need to call this initialize function in our first person character.
Default gravity.
So I'm going to open that back up, find the event begin play node, and I'm going to use a sequence here. So after this code is called, we're going to go ahead and call our initialize function. And we can pass in a reference to ourself. So now we're passing in a reference to this first person character blueprint to our parkour movement component.
Great.
Now there's two more events we're going to need. We're going to need a land event. And we're going to need a jump event. Similar to the initialize function, we're going to go ahead and call these from first person character.
Oh shoot, okay. Well, you know.
So we're going to need to find the jump event. Here it is. And we're going to call the jump event on the parkour movement component. Now for the land event, we're going to have to search for it. There it is, event on landed. And we're going to do the same thing. We're going to call the land event on the
Wait,
parkour.
there's an on landed? Love on landing when falling to perform action based on a hit result. There's an on landed event. What? Who was gonna tell me this? It even shows you what you hit. Holy smokes. That's crazy. That's crazy. No way. Brother, how did I not know about this? First of all, on landed. This again. I believe. Here.
Movement component. Now, if you'll recall,
We could test this. Front landed. test. Hey, that worked. What do you know?
First step is to stick to the wall. In order to do that, we'll need to shoot a raycast left and right of the character. And if it hits a wall, then we'll stick to it. So we're going to create a new custom event, call it wall run update event. And we'll call this right on our initialize function. We're going to set a timer, which calls this event. It's going to call it on a loop every 0.02 seconds.
For what reason?
Alright, so now we're going to create a function called wall run update. This is going to be called every 0.02 seconds. Just need to call it here. We're going to need the start and end point of our ray traces. Start point is just the character's location. The end point we're going to have to calculate.
For what reason do you need an event being called every 0.02 seconds all of the time? Why not just call that when you jumped? That's mad. What?
Macro. Location.
You know what?
Endpoint,
I'm just gonna do it.
2 seconds.
I'm just gonna
0.02 seconds.
see what happens. You know, what's the worst that can happen? See what happens. Set timer. Just, wall run update event. I guess.
Alright, so now we're going to create a
I
function
guess.
called wall run update. This is going to be called every 0.02 seconds. Call it here. We're going to need the start and end point.
Dude. Pause. Macro. Test. Delay. Input. Delay time. Okay, shoot, I thought I was onto something there. That would have been funny.
Of our ray traces.
I don't know what's going on.
We're going to need the start and end point of our ray traces. Start point is just the character's location. The end point we're going to have to calculate. So I'm going to make a new macro. Call it wall run end vectors. Now in here, we're going to need the character's location. And we're also going to need the character's right direction and forward direction. So the reason we need the forward vector here so that we can draw our raycast.
Wait, what?
And forward direction.
Okay.
So the reason we need the forward vector here so that we can draw our raycast slightly backwards instead of straight and off to the side. This gives us some wiggle room so that the character can rotate their camera while they're shooting, and they won't have to worry about falling off the wall.
When they're running, I'm guessing.
So now that
I
we
need
have
to
our
explain
vectors,
that
we can
better.
go ahead and start to calculate the left and right endpoints. I'm going to start on the right side, and I'm going to multiply my right vector by 75. That'll give us a length of 75 for the raycast. And I'm also going to multiply the forward vector by negative 35, just so that it's pointing slightly backwards to give us that wiggle room. Now we just need to add these three together. And we'll have our right endpoint. Now for the left, we just need to copy this over. And we just need to change this value here to negative 75. And that'll give us our left vector. Now we need a function that can take in these values and cast the ray and also perform the wall run movement. So we're going to create a new function called wall run movement. And in here,
I'm sorry, bro. You're moving mad.
so we're going to create a new function called
Why?
and that left vector. This value here to negative 75. And that'll give us our left vector.
Got it.
Now we need a function that can take in these values and cast the ray and also perform the wall run movement. So we're going to create a new function called wall run movement. And in here, we're going to call line trace by channel. This will allow us to do the raycast. We're going to pass in a start and end vector, and we're also going to need the direction and a float. We're going to use that later.
Let's need a what?
An end vector, and we're also going to need the direction and a float. We're going to use that later. So we need to split this struct and see if we get a hit. If we do, we're going to need to look at the normal of that hit and verify that it's a wall and not the normal. Split this struct. We're going to use that later. So we need to split this struct and see if we get a hit. If we do, we're going to need to look at the normal of that hit and verify that it's a wall and not the ground or some kind of slope or anything. We want to make sure that it's, perpendicular to the ground or at least close to that. So for this, we're going to make a new macro called valid wall run vector. Now in here, we're going to pass in a vector, and it's going to be the in vector. Now with this, we're going to want to break this, and all we really need to know is if the Z component falls within a certain range that we define. And I have this already figured out. This will work for us, for our use case.
Use in range of 0.5. What?
So from negative 0.52 to 0.52, and it will return true if this Z component falls within these values. And we can also output the vector as well. So now that we have that, we can go back to this and we'll make another branch, and we'll look at the out hit normal, and we'll make sure that it's a valid vector. another branch, and we'll
This is
look at
normal.
normal, and we'll make sure that it's a valid vector. Alright, so if it's a valid vector, we're actually going to save it. So let's promote this to a variable and save it as wall normal. And so now once we get to this point, we'll be able to do more with this vector. So now we have this saved. We should also check to make sure that the character is falling. So we can do that by getting the character movement and just checking if it is falling. And we'll check that. Now the next step will be to actually stick the character onto the
Oh, awesome. Awesome.
the wall. In order to do that, we're going to need to launch the character towards the wall.
We're doing what?
Now the next step will be to actually stick the character onto the wall.
Okay.
In
Stick
order
the
to do
character
that,
onto
we're
the
gonna need
wall.
to launch the
Wall run movement. Look for wall. Wall hits. Valid wall. And falling. Get the normal.
character towards the wall. And we're not going to use the wall run normal, we're actually going to use the opposite of that. So we can make another macro for that.
Grab that a
Call
second time.
Player to wall vector. So this is just going to return a vector. Normal, we're actually going to use the opposite of that. And we're not going to use the wall run normal, we're actually going to use the opposite of that. So we can make another macro for that and call it player to wall vector. So this is just going to return a vector and it'll be from the player to the wall. So we'll output a vector. And we'll need the actor location. We'll also need the wall run normal here. Now we're going to subtract our location from the wall normal. Now we don't want to continually push the character onto the wall. We want to stop once we get close enough. So to do that, we're going to get the length of this vector.
Oh, shoot!
And it'll be... We'll also need the wall run normal here.
I said I skipped forward. Okay.
Now we're going to subtract our location from the wall normal. Now we don't want to continually push the character onto the wall. We want to stop once we get close enough.
Okay.
So to do that, we're going to get...
Wall run normal minus the actor location. Is that... Is that pointing it towards the wall? Is that what it's doing?
the length of this vector, and we're actually going to multiply the wall normal by it. And this is the vector that we return. So as we get closer to the wall, the player will be pushed less and less. With this, we should be able to stick the character to the wall. So we'll go back to the wall run movement, and we'll use this macro that we made. So as we get closer to the wall, the player will be pushed less and less.
Got it. That
With
actually
this,
makes
we should
sense.
be able to stick the character to the wall. So we'll go back to the wall run movement, and we'll use this macro that we made as the launch velocity. We're also going to need to launch the character forwards so that they stay on the wall and they move in a consistent way. So we're going
Wait, to what?
character forwards
Okay.
so that they stay on the wall and they move in a consistent way. So we're going to launch the character again. This time we're going to override the XY movement, and we're going to
Okay.
calculate the forward direction. So for this, we actually need the wall run normal, and we're going to need the cross product of that and up, so Z1. Now this cross product will give us either forwards or backwards, depending on
Dang, man, the cross and the dot product always had me in a loop. I never really knew. Like, what?
what wall we're on, if we're on the left or the right side. So that's where the wall run direction comes in, actually. So we're going to use that.
The cross
We're gonna
product.
So that's where the wall run direction comes in, actually.
Cross product. The vector. So the cross product gives oh, that's this. So the cross product gives the freaking perpendicular. Got it. Ah, shoot. Okay. So the cross product, if there's two... What do I look like right now? Okay. If there's two angles, like, let's two vectors going like this. The cross product goes freaking this way. It's like the... So the cross product of the wall normal, which is this way, and up, it looks like this. So this is the wall, this is the wall normal, that's where it's pointing, and then one on the Z is upwards. That means the cross of that is gonna go that way. But essentially it's gonna kind of choose the direction. It's like this, right? A is index finger. Okay. So wall run normal. A, B. So it's actually gonna go this way. If the wall is pointing this way, the cross actually gonna be this way. So inherently left. Inherently left. Right hand roll. That's super cool. Totally forgot about that. Cross product is perpendicular. So right here, it's gonna shoot it out left.
So we're gonna use that.
Yeah.
And we're gonna make a new variable for wall run speed. Now we're going to multiply our speed by the direction.
Oh. We actually don't want that. Wall run speed. Get move speed. Get move speed. What is that getting? I'm guessing it's in here. This slows down my computer. Find quick move speed. It's not. Is it here? Command F to find results. Quick move speed. It is in that. I'm a genius, but why didn't it pop up? It's just the ground speed. Awesome. Cool. Cool, cool, cool. So, forward direction. I want to get this. Get anim instance. Mesh. Get movement. Speed. So when we're about to launch him, the speed at which we are launching this boy across the wall going to be his own movement speed. attach to wall here thing, and then
direction, and we'll use that as a multiplier for our forward vector. Now we plug this into the launch, and now what this will do is move our character forward. Now if we want to make it like Titanfall, we can override the Z as well, and then you'll run in a straight line on the wall. That's how a lot of games do it. But like Titanfall, we can override the Z as well, and then you'll run in a straight line on the wall. That's how a lot of games do it. So we'll call this wall run gravity. So if wall run gravity is not true, then we won't use gravity. But if you want realistic gravity to work while you're wall running, then you can go ahead and leave this turned on. We're going to set the wall run speed to a default value, say 850 units.
okay, that feels really nice.
Wall. So you'll run in a straight line on the wall. That's how a lot of games do it. So we'll call this wall run gravity. So if wall run gravity is not true, then we won't use gravity. But if you want realistic gravity to work while you're wall running,
awesome. You can set if you want gravity or not. That's super cool.
you can go ahead and leave this turned on.
Alright.
We're going to set the wall run speed to a default value,
Wall.
say 850 units. And we can go ahead and return true here. So this will tell us that we are on the wall and it was successful. Now we need to go back and actually return false wherever the wall run failed. So if we didn't hit a wall, or if it wasn't a valid wall, or if the character wasn't falling. So this will stick the character to the wall, and this is going to, or if the character wasn't falling. So this will stick the character to the wall, and this is going to move the character forward. So now that we have that set up, we can go back to our wall run update function and call our wall run movement. We'll start on the right side. Our direction is going to be
Okay, so the whole thing that we just made right here.
-1,
Or
and we're going to pass in our start and end vectors. So that's going to be, the start vector is going to be the actor location, and the end vector is going to be our right end point. So if we do hit the wall on the right vector, we're going to go ahead, we're going to actually create some new variables here. So want a variable, see if we're wall running in general, and then we want vector. We're going to go ahead, we're going to actually create some new variables here. So want a variable, see if we're wall running in general.
Okay.
And then we want 2 more variables, one for the right side and one for the left side. So we'll say we are wall running, right wall. And we're not on the left wall. So we and we're on the right wall.
Okay. Hold Alt, back it off. Make set. Wall running right. If you're on the right, then you're automatically not on the left. Right?
And we're not on the left wall.
I don't think that's necessary at all.
So if we go back to our outline here, we'll see that we did stick to the wall. Now we need to drop the gravity. So to do that, we're going to smoothly interpolate the gravity of the character to our target gravity. So we're going to get the character movement.
Somebody just set up a mad firework. Holy goodness.
And we're going to...
One sec. Let's organize this. Wall. Settings.
Interpolate. So the current gravity is our current gravity, and then the target
Scale.
can promote this to a variable, call it wall run.
Temp current gravity.
Target gravity. And we can set this by default to 0.25. Now we need our delta time, world delta seconds, and for the interpolation speed we can just set it to 10.
What if the gravity was changed though? We'd want it to know. So fine. We'll cross the bridge when we get there. I didn't want to do this, let it be clear. Let it be known. Didn't want to do that. But I did it. Here. Chirp. Current. Target. Gravity. Base setting. Float.
We can just, now we need our delta time, world delta seconds, and for the interpolation speed we can just set it to 10. And we're going to set the gravity scale of our character to this value here. Next we'll do the left side. So we're going to branch off of here, and we're going to check if we're already wall running on the right side, and if we're not, that means we're not wall running at all, so we're going to have to check the left side. We can just copy this over.
Okay. Right.
And instead of the right side, we'll do the left side, and then we'll change our direction to 1. Then we can copy this up here. And instead of wall running right, we're going to be wall running left. And then we're also going to change the gravity.
Hey. Now we can
So that looks good. The next thing we need to do
running right. Left. Else we are not walking.
do is make a function to reset everything basically and end the wall run. So we'll call this wall run end. We're going to set all these booleans to false. reset the gravity. To do that, we'll get the gravity scale. We're going to set the gravity scale to the default gravity. And that's it. So now we can go back to our wall run update.
Dang, this dude does not waste a second. I dig that. Dang. Scale. Gravity. I think all it should care about is that.
And that's it. So now we can go back to our wall run update and we can call wall run end. So this is basically the case of we're wall running to our right and we're not doing that anymore. And this is the case if we're not wall running to the left or the right. Now if we're booted from the wall run, we're not going to want to allow the character to continue checking right away. So we're going to create a new variable called wall run suppressed. And we're going to make a function called suppress wall run. Down here, we'll set this to true. And we'll pass in a delay so that we can set this back to false. So what we'll do is we'll set a timer by function name, and we'll call this function reset wall run suppression. So we're going to suppress wall running and then bring it right back. So in the wall run end function, we can also do the same thing here. We'll add an input for the reset time, and we can pass that into the suppress wall run function. For this to work, we're going to need to create a custom function with this name so that we can reset it. So go back to our event graph, make a new event, reset wall run suppression, and then we'll just set this to false. We also should clear any other timers so that if any other function calls this, it's stopped. So we'll just paste that back in there too. So now we'll come in here, clear any other timers from anywhere else, and just set this back to false. Now we go back to our wall run update function and we set the reset time to 1. So that way, if you're booting from the wall, you get about a second, and that gives you enough time to land and try again. So we just finished dropping the gravity. Next up is tilting the camera. So we're going to go back to our event graph, and we're actually going to use the event tick here. Event graph. Enough time to fall. You get about a second, and
I'm gonna make that a freaking variable. Reset wall one time. Float. Settings. Here.
And that gives you enough time to land and try again. So we just finished dropping the gravity. Next up is tilting the camera. So we're going to go back to our event graph. And we're actually going to use the event tick here. Make a new function called camera tick. And in here, we're going to tilt the camera differently depending on if we're wall running left or right.
Okay, so this I don't really think I need.
So we'll call it
Awesome, awesome.
And it's working. All this.
I feel like I didn't plug something in somewhere.
Right. Actually gonna use. So we're gonna go back and drop into our event graph.
This needs to.
And we're actually going to use the event tick here. Make a new function called camera tilt.
Okay.
So
What about the jump and land events?
and it's working. Now we do have one problem. We need to be able to jump off of the wall. So to do that, we go into our jump event here. And we're going to make a new function called wall run jump. Now again, we only want to call this if we're wall running.
Jump.
So we're going to check that first. And if we are wall running, then we want to end the wall run. We'll make this a shorter time, that way you can string wall jumps quickly. Now we want to launch our character. We're going to launch him up and off of the wall. So we need to over.
And
override the Z, and we can actually make this a variable, so we'll promote.
wall. And then apparently we're going to want to launch the character again. Who would have thought? Launch character.
This to a variable. Call it wall run jump height. I'll set this to 400. velocity for X and Y. We'll calculate that based on the wall run normal. So we'll break this, and we can multiply X and Y by a multiplier. So we'll promote this to a variable, and we'll call it wall run jump off force. And we can do that for Y as well.
Jump off force. Okay.
So that's going to be our X and Y values here. So not only will we jump upwards, we'll also jump away from the wall we're on once we hit jump. So now we need to call so jump. So we'll promote this to a variable, and we'll call it wall run jump off force. And we can do that for Y as well.
I guess we'll just set to 402 for now.
So that's going to be our X and Y values here. So not only will we jump upwards, we'll also jump away from the wall we're on
Sick.
once we hit jump. So now we need to call this function in our jump event. We should also end the wall run event if we land. So we can call wall run end. We can reset it right away, and we can set wall run suppressed to false. We also need to make sure that we're not calling the wall run update if wall run suppressed is true. So this will allow us to jump from the wall without it pulling us right back. Now we can set our jump off force to 300. We also need to make sure that the wall run end event isn't called all the time, because it's going to keep resetting the wall run. So we want to make sure it's only called once if wall running is true.
Careful. Just through. Okay.
So we stuck our character to the wall, we dropped the gravity, and we tilted the camera. Now we should have a fully functional Titanfall style wall running. So let's test it.
Yo, if this works. Let's do something. Tools. Pixel bridge. Let's grab something that looks pretty. Um, I'll be right back. Hang on. All right. Okay. Let's look for 3D assets. thing. Wall. Dang, you can just build your own thing. I guess just a modular stone wall is the best bet. Okay. Grab this nanite wall. Download it. By the way, this is part of UE5. It gives you Quixel Bridge right in the editor. So you can just look for anything. I'm downloading a nanite asset right now. Downloaded it. Let's add it. Ooh. Nice, yeah, 3 asset. Industrial. Interior. It's in collections. Ooh. What? Castle ruins. Oh, that's sick. Look at all this stuff. You can just... What? You just draw it on a path or what? Wait, actually. It's like a medium quality path. cobblestone path. So when I go to here, whoa, what happened? Got it. That's fine. Oh, I forgot. Can you add like a can I just go to the next spline point? Texture. Huh. How to add texture to a spline. Number 5. Static mesh texture spline. Click on the spline control point on the landscape. In the level editor details panel in the landscape spline section. Next, you select all connected. Click segments. Just add one. Okay. Level editors, details panel. Landscape spline section. Next to select all connected. In the landscape spline section. Okay. Next to select all connected. Click the segments button. Line meshes. Oh. Whoa, something just moved. What is search? Mesh. Uh. Okay. Guess I can't. Let's say come down here. Line mesh. Do I need to add a line mesh? Take scans. Surface. Where did I put it? cobbled. Here we go. But okay, so I guess that is just okay, well that didn't work at all. Unlucky. We're gonna do come in here. This. Oops. your time. It's all good. Take your time. All right. Care about either of these. Let's make this guy a little bit more grand. Dang, little wall. Okay, well that didn't help. Physical material. Open this real quick. Cool. Collision. Awesome, it has collision on it. Or so I think. Yes. Holy smokes. Oh my goodness gracious. It is so annoying to have 0 frames. Holy smokes. Oh, let's see it. Show FPS. Oh, 5 frames? That's great. Perfect. Alright. Well, to test this one, I'm gonna dip. But it's been fun. Had a cool small stream. Hopefully this works. I'll have to let you guys know next time, because I got no frames. But till then, thank you for coming along. If you'd like to see more, if you'd like to learn more about the game and why I'm putting walls in and having a wall run and that sort of thing, go ahead and check out the link in the description. We have a TikTok and an Instagram, a bunch of stuff there that you, I'm sure, will find at least a little bit interesting. And if you'd like to support us for making the up-and-coming game Haurmon, go to our Patreon down in the description. You can also support us right through Streamlabs, which is the OBS that I'm using to stream this. Thank you to them. Yeah, I will see you guys next time.